Then next is the buffer solution. There are two types of buffer solution: acidic buffer solution and basic buffer solution. This point is already you are studied in a regular lecture. I only overlook this point. How will you calculate pH of buffer solution? What is meant by buffer solution? Buffer solution is the solution which resists drastic changes in pH upon addition of either small amount of strong acid or strong base. How will you calculate pH of buffer solution? Formula for pH of buffer solution is equal to pH is equal to pKa plus log to the base 10 concentration of salt divided by concentration of acid. Similarly, pOH of buffer solution can be calculated by formula pKb plus log to the base 10 concentration of salt divided by concentration of base. By using this formula, we can calculate pH of buffer solution. There are two types of buffer solution: acidic buffer solution. Acidic buffer solution is composed of weak acid and salt of weak acid with strong base, called as acidic buffer solution. Then basic buffer solution. On this point, some numericals will be asked. First, calculate the pH of buffer solution. Question is, calculate pH of buffer solution. pH of buffer solution containing 0.06 mole of sodium fluoride per liter and 0.018 mole of hydrofluoric acid per liter. Here, dissociation constant for acid is given. Ka for HF is equal to 7.2 into 10 raised to minus 4 for HF. Here, value of dissociation constant for acid is given. From this we can identify which is acid and which is salt. Here Ka for HF is given, that is 7.2 into 10 raised to minus 4. Therefore HF is the acid and remaining sodium fluoride is the salt. Salt of strong acid with. Then how will you calculate pH? pH is equal to pKa. First of all, we have to calculate pKa. What is the formula for pKa? pKa is equal to minus log to the base 10 of Ka is equal to minus log to the base 10 of Ka 7.2 into 10 raised to minus 4. Here minus minus plus 4 minus log to the base 10 7.2, 4 minus log of 7.2 equals to log of 7.2, that is 8573 by calculating 4 minus 0.8573, it becomes equal to 3.1427. This is the pKa, 3.1427. Then substituting values in this formula, pKa is equal to 3.1427. Concentration of salt, that means concentration of sodium chloride, 0.06, and concentration of acid is equal to 0.018. Then substituting, pH is equal to pKa 3.1427 plus log to the base 10 concentration of salt, that is 0.06, divided by concentration of acid 0.018. By calculating, pH is equal to 3.1427 plus log to the base 10, this is the 3.333. Then pH is equal to 3.1427 plus log of 3.33 is equal to 0.5229, and by adding, pH is equal to 3.6656. In this way we can calculate the pH of any buffer solution by using this formula. Then next is the solubility and solubility product. This point is very important. Number of times question was asked in NEET examination. Next is the solubility and solubility product. Solubility, it is denoted by capital S, and solubility product denoted by KSP, the solubility product. First of all, how to write equation for or expression for solubility product. For example, barium sulfate. Barium sulfate is the sparingly soluble salt. It can be dissociated into Ba2 plus SO4 minus 2, and we know that here coefficient of or number of moles of barium plus 2 ions is 1, and number of moles of SO4 minus 2 ions is also 1. Then KSP is equal to concentration of Ba plus 2 multiplied by concentration of sulfate ion. This is the expression for solubility product of BaSO4, barium sulfate. Then second example, how to write solubility product of calcium fluoride. Calcium fluoride CaF2, it can be dissociated into calcium plus 2 ions plus twice fluoride ion. Then here number of moles of calcium plus 2 ions is 1 and number of moles of fluoride ions are 2. Therefore, solubility product KSP is equal to concentration of calcium plus 2 into concentration of F minus raised to power 2. This coefficient is raised to power of concentration term. Then third example, Bi2S3. Write what is the solubility product expression for this sparingly soluble salt 2Bi plus 3 plus 3S minus 2 sulfide ion. Then here number of moles of bismuth is 2 and number of moles of sulfur is 3. Therefore, solubility product is equal to concentration of bismuth plus 3 ions raised to power 2 multiplied by concentration of sulfide ion raised to power 3. Then third example, third is the relation between solubility and solubility product. That is, solubility means capital S and solubility product means KSP. What is the relation between solubility and solubility product? Formula for calculating relation is equal to KSP is equal to x raised to x, y raised to y and x raised to x plus y. In this formula, x is the number of moles of that particular ions. X is the number of moles of cations and Y is the number of moles of anion. For example, in calcium fluoride, here 3 examples are written. For barium sulfate, X is equal to 1, Y is equal to 1. Let us calculate the relation between solubility and solubility product for these 3 sparingly soluble salt. First, for barium sulfate, X is equal to 1. For barium sulfate, coefficient of barium plus 2, that is number of moles of barium plus 2 is 1. X is equal to 1 and Y is equal to also 1. Then in second example, calcium fluoride, X is equal to 1 and Y is equal to 2. In third example, X is equal to 2 and Y is equal to 3. Then let us calculate the relation between solubility and solubility product for these 3 salt. First is for barium sulfate. For BaSO4, KSP is equal to what is the value of X? X is equal to 1. Therefore 1 raised to 1. What is the value of Y? Also 1. Again 1 raised to 1. And S raised to X plus Y, that is 1 plus 1. Then KSP is equal to S raised to 2. This is the relation between solubility product and solubility for barium sulfate. Then second is the for calcium fluoride. For calcium fluoride, X is equal to 1 and Y is equal to 2. Then KSP is equal to X raised to X, that is 1 raised to 1, Y raised to Y, that means 2 raised to 2, and S raised to x plus y, that means 2 plus 1, that is 3. Two raised to 2, 4s cube. This is the relation between solubility product and solubility for calcium fluoride.